Let's find the average value of f of x equals 2x e to the x squared on the interval from 0 to 1. The formula we just came up with says that average function value will be 1 over 1 minus 0 times the definite integral from 0 to 1 of our function 2x e to the x squared dx. Now we are going to need a u substitution to evaluate this definite integral. Let's let u be x squared, then du will be 2x dx. I'm going to go ahead and change the limits of integration to u's also. When x is 0, u will be 0 squared, which is 0. And when x is 1, u will be 1 squared, which is also 1. Putting that stuff in, first of all, 1 over 1 minus 0 is just a 1. So we don't really need that. And then our integral is just turning into e to the u du, going from 0 to 1. Antiderivative for e to the u is e to the u, going from 0 to 1. Then we have e to the first power minus e to the 0 power, which is e minus 1. Let's see another example. We're given the graph of a function f of x, and we're asked to find its average value. Even though we don't have the formula, we don't even know what any of the values are. So how are we going to do this? Well, let's go to our formula for the average value. We know it's going to be 1 over b minus a, that's 4 minus 1 in this case, times the definite integral from 1 to 4 of f of x dx. Now, we don't have a formula for f, but we're given the areas above and below the x-axis between 1 and 4. And remember, the definite integral from 1 to 4 will give us the cumulative area going from 1 to 4. First, we have an area above the x-axis of 1. Then we have an area below the x-axis of 5. And remember, areas below the x-axis are registered by the definite integral as a negative. And then last, we have more area above the x-axis. That area is 9. So the value of that definite integral we can see from the areas is 5. Therefore, the average value of our function from 1 to 4 must be 5/3. We often use averages as representative values. For example, when we take the average of a finite set of numbers, we can often use that average as a representative of the entire set of numbers. For example, suppose a student's grade depends on the sum of 3 test scores, and their scores are 70, 75, and 90. Well, the average test score is, of course, 70 plus 75 plus 90 divided by 3, which is 78 point repeating threes. What do I mean by taking this as a representative score? One way to look at that would be to say the sum of the 3 scores you can get by just taking that average representative score and multiplying it by 3, And that gives you the actual sum of 70 plus 75 plus 90, which is 235. So multiplying the average score by 3 gives you the same numbers if you actually added up the three numbers. Something similar is going on with our function average. With that, we have our formula that says the average value is 1 minus b over a times the definite integral from a to b of f of x dx. If I multiply both sides of this by b minus a, I get that the average score, or the average function value rather, times b minus a would give me the definite integral of all those infinitely many function values over a to b, over the interval from a to b.